everyone. So let's talk about today's class thread. So right now we move on to thread. What's a thread? Thread is the best unit for multi-threading, for multitasking. So far we talk about a process, right? So for process, you can create a new process to do a different job. For example, you can create a child process to handle some command in your shell. So your shell can like still receive like a further command from the user, right? So this is one like example of multitasking we covered so far. But you probably think in this way: the process is like really hard to communicate between process. So far we covered a signal, your signal to communicate, but the signal is not so so important, like so useful because the signal is predetermined. So you cannot send a random message to another process by using signal. So how to do it? Actually, there's another stuff called thread. It can like easy share the data in a process. So what's a thread? How to use it? Today we will talk about the basic concept of a thread. So imagine that you have a process. For your process, you try to do like a fork. So after you do fork, you actually like create the same one, like a same code, same content in the process. So you copy everything in your process and put into another process. So actually they are independent to process and they have the same code here and they just do execute their code. So you can use if else statement to separate the child process and parent process, but still they refer to the same code. And each process has individual memory, so they are independence to each other. So it's hard to communicate to each other because the memory is independent. If you want to like communicate to others, you need to use IPC, inter-process communication, some other inter-process communication you can use to send a message between these two processes. Okay, but today we'll talk about thread. Thread is a new one. Thread is totally new one. Thread is not like a fork. So when you create a thread, actually you can imagine you just create one hand in the same process. You create a couple different hand in your process, and each hand can do different stuff, but still they belong to the same process. So imagine that you only have one process, and inside of one process, the code here, you try to separate the code to code part one, code part two, code part three, your process. And every memory space here is sharing, not actually they are not share everything, but we will talk about the detail. But you got the idea. It's every information is in the same process, so it's easy to access the data in the memory no matter which thread going to check this memory. Okay, so this is a basic idea of a thread. So if we look at the thread concept here, so actually thread has an individual stack for each thread. So for example, the thread one, the main thread, actually the main one, the first thread you have in a program before you create another thread, the main thread has its own stack. So when you use some like a function to create another thread, then you create another thread with another stack. So you got the second stack here. Okay, so actually each thread has their independent stack, which means they have their independent local variable argument systems. However, they share the same global variable, static variable, and heap. So it can make your code really easy to be implemented, right? Because you can use the global variable, use a heap to store the data you want to share in different tasks. But you can also keep some local variable belong to each task. For example, if I want to play um, a ball game right now here, I have a ball game, very interesting ball game. But I I don't have a friend. If I don't have a friend, only myself, how can I do? Create the thread, right? I can write a program to create a thread. So I create some program as a as my just like myself. So it's called friend A, B, and C, and this is myself. Then we can use the program. We can use the game to like play together. But how to create the thread? Why we need the thread? Why do we need process? Because the board, the board is shared information, right? So if you want to pass this board information to other process, it's like definitely expensive and hard to maintain. So if we can put this board as global variable, and each thread has its local variable, which can be the strategy and so on, like the algorithm, then it's easy to implement a board game plate by using a thread, right? So this is something you can think about in your video games, in like some like interesting software. You will need like a couple different features to work together. They usually use thread. Why? Because easy to share. So I think the key for a thread here is the sharing. So when we talk about thread, why we need thread? We want share. Why the thread is terrible? Because of sharing. We will talk about this later. All about sharing. Okay. So if you don't need to share, you probably can think about just use process to do it because it's much safer. But if you want to share the data, the thread is the very easy way to implement your program. So in summary, what's the thread look like? Actually, multiple thread, they belong to in the same process. So they share the same process ID. If you call get PID in different thread, you will see the same data. They share the same information in the global variable, the uninitialized data and initialized data, the global variable, static variable, and also on heap. Everything you do the malloc, you can share it on a heap between like the thread. And each thread has its own stack. So it's the local variable argument this stuff belong to each thread itself, but they can share its other variable, like a non-local variable. And of course, you inside the text the program code, you have like separate lines of program code to manage like if each different thread. And I will show you an example in other videos. Okay, so this is the summary, an overview of your thread. Okay, so let's talk about why we need the thread. Why we need the process? Why don't we need process? Why don't we need thread? Okay, so what's the benefit to use process? What's the benefit to use thread? The first one, we know the benefit to thread is sharing because it's easy to share data. Easy. Of course, if it's easy to share, means the process is hard to share. You can still share the data by using inter-process communication. Use socket, use pipe, use signal to like send the data. But it's hard to share, right? So actually, you can also see it's expensive to share. Okay, so this is the first part. The second part is expensive to create it. If you are talking about a process is expensive because you want to copy every content from one process to another one. You copy a lot of data to another process. But a thread, you don't need to. You just like do like some duplication inside a process. It's much easier. So if you got this one, actually this is expensive. But the thread is cheaper compared to the process. So this is a two benefit we use the thread. We want to share, we want to save some resource, especially the system resource. Okay, so what in which like in which why we need to process? Why we need process? So the process, the disadvantage is about it's hard to share, but the benefit is sharing. So it's safe. So why it's safe? Because it's hard to share. So everything you put, you manipulate in the process won't change another process behavior. So it won't like affect other like stuff. And if you change something like not in your process or not in your thread, of course it can make some confusing, right? So if you have some mistake, so actually this is safe means how to make the mistake. mistake on memory. Okay, so this is the benefit. So in other way, the thread, because it's easy to share, so it's unsafe. What's unsafe? Unintended sharing. So this unintended sharing means it's not in purpose. You don't want to share, but you just got a bug. You just have a bug. You forgot to check it, and you got a bug. It's really hard to debug. It's hard to debug on this unintended sharing. So it's easy to give you some trouble as a programmer, easy to give some like unexpected output result. And you don't know what happened because this unintended sharing, you haven't checked it, it's caused this problem. So this is unsafe. Okay, so this is the benefit to use process. This is the benefit to use thread. This is the disadvantage to use process. This is the disadvantage to use a thread. So in conclusion, when we use process, when we use thread, if you want to do a lot of sharing, please use thread because it's like reduce your resource, the number of resources you need. It's also like make your code faster. It's easy to share. But if you don't have a lot of sharing, you basically each process is run independently. They only need like few like interaction. Then you should consider to use process, not a thread. Okay. So this is the comparison between the thread and process, and this is very important, like a comparison concept. Okay, so this is for today's video. We just briefly introduce what's a thread and what's the difference between thread and process, and which is better, what's the benefit to use thread compared to the process, what's the benefit to use process compared to the thread. So we talk about this basic concept of a thread, and we will talk about how to program a thread in the next video, okay? So hope you enjoyed today's video. See you next time. The thread is awesome.